So in this video, I'm going to take you through solving linear inequalities with one variable. So solving linear inequalities, it is very similar to just solving linear equations. There's just a few little things that we're going to have to pay attention to that are new, and we're going to talk about this specifically in the very last example. So in the very first example, when solving the linear inequality, I would just start by combining like terms. So I would move the -5 to the opposite side by doing inverse operation, which is adding 5 to each side. So I would be left with 2x is greater than or equal to 8. Then dividing each side by 2, the 2's will eliminate, and we're left with x is greater than or equal to 8 divided by 2 is 4. And then you can graph it later on. And anytime you want to check your work, you would substitute that value, the 4 back, or any value that is greater than 4. So if you, let's say, want to substitute 5. So does x equals to 5 work? You would take the 5 and plug it in for x to see if it's going to actually come out to be greater than or equal to 3. 2 times 5 is 10. 10 minus 5 is actually 5, and 5 is greater than 3, so that would work. So for example number 2, again, we would first subtract 1 from each side, and we would be left with 3x is less than or equal to 7 minus 1 to get 6. Divide each side by 3, and I'm left with x is less than or equal to 2. So notice I'm just solving the equations the exactly same way, keeping the exactly same sign. And you can check your work if you like to. For the next example, example 3, I would use the distributive property first. So 2 times 3x, that's 6x. 2 times -1, that's -2. Then adding 2 to each side, I would be left with 6x is greater than -14 plus 2, that's -12. Dividing each side by 6, and you would end up with x is greater than -2. Okay? And the last example is the most interesting, because that would be an example of when actually we have to change the inequality symbol. So here we're going to combine like terms. So maybe we can just start from subtracting 6x to move the x terms on the left. And I'm going to add the 5 to each side. So actually we'll do 2 steps at once. So 4x minus 6x, that's -2x. The 5's will cancel out. 6x minus 6x, that's going to eliminate, and 3 plus 5, that's 8. Notice here that we would have to divide by a negative coefficient. Anytime you have to divide by a negative number or negative coefficient, your inequality symbol would flip-flop. Okay, so it flips spaces. And you would be left with x is less than -4. I think so this example is worth checking to make sure we got it right. And what I'm going to do here is I'm going to label that inequality symbol flip, okay, because you were dividing by negative number. That's pretty bad. So divide by negative number. All right, so let's go ahead and check any value. Now, in this case, it wouldn't make sense to substitute -4 because the solution isn't -4. The solution is all the values that are less than -4. So if you think about the number line, all of the numbers that are to the left of -4 are -5, -6, and so forth. So let's go ahead and substitute, let's say, -5. So I'm going to check to see if that would work for when x is -5 by substituting x in each x in the equation. By substituting -5, sorry, for each x. Okay. Here we go. So 4 times -5, that's -20, minus 5. 6 times -5, that's -30, plus 3. -20 minus 5, that's -25. -30 plus 3, that's -27. Is that true that -25 is greater than -27? Yes, it is. So that is it. Yay!